Hello there, this is Miss Ui here. The aim of this video is to work on exercise 6D, but before that, I just want to perhaps go through a little bit on 6C, the end part of 6C. And, in the last lesson, I went through this in class, but I went through it very quickly. Perhaps you may want to pause the video and try part E. By the way, you need to pause the video and go and get your notes if the notes is not in front of you, and like you to fill in the blank of your note as we go along this video. Okay, let's look at part E. So this is to do with Pythagorean identity. And remember here that cos square theta plus sine square theta is equal to 1 come from the theorem Pythagoras. The square, if you have a right angle triangle, the square of the two shorter sides is equal to the square of the hypotenuse. So square of cos, so it's cos square theta plus sine square theta equal to 1. And as I mentioned in class before, cos square theta will be equal to 1 minus sine square theta, which gives you cos theta is equal to plus minus 1 minus sine square theta. So if you know sine, you can actually find cos. And we know that mathematically you should plus and minus, but when you work on the questions, usually you will be given which quadrant. So if you're looking at the second quadrant, cos will be negative. If you're looking at the third quadrant, cos will be negative. If you're looking at the first and the fourth quadrant, cosine will be positive. Okay, and for sine theta, we can say that it is square plus minus square root of 1 minus cos square theta. Now, there is another method to find sine, cos, and tangent by just simply drawing the right angle triangle. So I want to look at part E. You're given cos x equal to 4 and 5, 4 over 5. So let's draw a right angle triangle. That's 90 degree here. Cosine x is basically adjacent over hypotenuse. So therefore, we can use the Pythagoras theorem to find out the other shorter side. That will be the square of 5, which is 25, minus the square 16, which is square root 9. And we know that that is actually equal to 3. And we know the Pythagoras tried 3, 4, 5. So I expect all of you to know that that's just 3. So now I want to find sine x. So looking at the diagram, sine x is opposite, which is 3. Hypotenuse is 5. And tangent x is just 3 over 4. But this is if we're assuming it's in the first quadrant. Now let's answer the questions. We're interested in x lies between 3 pi and 2 and 2 pi. So I'm running out of space. So 4x more than 3 pi 4. Okay, where can I write? I'm going to write it here. So 4x lies between 3 pi and 2 less than 2 pi. And which quadrant are we looking at? We're looking at the fourth quadrant. In the fourth quadrant, sine is actually negative. We know that sine x is negative. So therefore, your sine x should be negative 3 over 5. Okay, and tangent x is also negative because at fourth quadrant, tangent is negative. So we say that tangent is actually negative 3 over 4. So this is our answer. Okay. All right, example 6. Pause the video and have a go, and then come back when you're finished. All right, let's look at this together. Sine alpha is 0.6, cos beta is 0.4, tangent theta is 0.7, alpha beta theta is between 0 to 0.2 radian. So basically alpha beta theta, they're acute angle. Find the following cos of negative beta, which is the same as cos beta. Now, some of you say, how? You ask me how, I'll tell you how. Negative beta means that you're measuring angle from the clockwise. So cosine is this x value. Cos of negative beta, that's x value. Let's draw the same triangle on the other side. If this is negative beta, that will be beta because it's the same. So can you see here cos of beta? All right, cos is adjacent over hypotenuse, yeah? Our hypotenuse is 1. So can you see cos of beta and cos of negative beta, they're the same thing, same x value. So therefore, it's 0.4 in this case. You're given cos beta is 0.4. Cos theta, how do you find cos theta? We know tangent theta is 0.7, which is equal to 7 over 10. Now, let's make use of this right angle triangle. Let's draw a triangle, and let's put a theta here. And we know the tangent is basically opposite, which is 7 over adjacent, 3. Okay? And we can work out the hypotenuse, which is a square root of 10 squared plus 7 squared. So 10 squared is 100, 7 squared is 49, so it's 149. So square root of 149. So cos theta is adjacent over hypotenuse, and the thing we can reduce further, so we leave it that way. Now sine pi and 2 minus beta involve pi and 2, so we know that there will be a swap of sine become cosine beta. Sine pi and 2 minus beta is in the first quadrant, is pi and 2 minus beta, so we're looking at here. All right, so first quadrant, everything is positive, so therefore the sign in front of cos should be positive too. Cos beta is 0.4. Okay, the next question is cos of pi and 2 plus alpha. Again, think of whereabout is this in the unit circle, pi and 2 plus alpha. So it's in my second quadrant. In the second quadrant, cos is negative, so put a negative sign. Now, because of pi and 2, cos has turned to sine of the angle alpha. So negative sine alpha, which is 0.6, so it's negative 0.6. All right, part E. Tangent pi and 2 minus alpha is equal to 1 over tangent alpha. Okay. Now, do we know tangent alpha? We don't know tangent alpha, but we do know sine alpha. You're given as 0.6, which is 6 over 10, which is 3 over 5. Again, we can use this right angle triangle to help us, and using the trig ratio. So alpha sine means opposite over hypotenuse. So we know that that has to be 4 here. So sine alpha is 3 over 5. And tangent alpha, it will be 3 over 4, which is opposite over adjacent. So 1 over 3 over 4, which give you 4 over 3. The last part, sine of 3 pi and 2 plus alpha. 3 pi and 2 is here, plus alpha. So we're looking at fourth quadrant. Fourth quadrant, the y sine is about the y value, so we know the y value is negative, so put the sine first. And because of 3 pi and 2, so sine become cos of that alpha. So negative cos alpha, again, we do know from this triangle, that triangle that we got here, cos alpha is actually just 4 over 5. So it's negative 4 over 5, and that's it. So for example 6, and let's move on to the next section. All right, pause the video and have a go with this question. Okay, welcome back. So let's look at this question together. We're given sine x equal to 0.3, cos alpha is 0.6, tangent theta is 0.7. So let's look at part B. We have sine of pi over 2 plus alpha. Can someone tell me what happened to sine when you see pi and 2 involved here? I can hear some of you say they'll be swapped to cos. Sine turn to cos and put alpha here. Now, pi and 2 plus alpha, where about in the unit circle? That is in the second quadrant, pi over 2 plus alpha here. The sign means the y value, which is a positive y value. So therefore, positive cos alpha, which is 0.6. Okay, next question. Sine of 3 pi over 2 plus alpha. 3 pi and 2 plus alpha, it is here, which is in the fourth quadrant. In the fourth quadrant, sine become negative, but because it's involved 3 pi and 2, remember I said in class that sine, there'll be a change of sign, become cos alpha, so that become negative 0.6. Okay, now k, tangent 3 pi over 2 minus theta, that'll become 1 over tangent theta. All right. Okay, so 1 over tangent theta, 3 pi and 2 minus theta. So 3 pi and 2, 3 pi and 2 minus mean going backward. So that should be the position we're looking at. And it's in the third quadrant. The quadrant tangent is positive. So it's 1 over 0.7, which is 1 over 7 on 10, which is equal to 10 divided by 7. Okay, last one. Cosine of 5 pi on 2 minus x. 5 pi and 2, where's 5 pi and 2? Is basically 2 pi plus pi and 2 is here. So negative means going clockwise direction. So it's in that positions we're looking at. So cos will become sine because it involves that pi and 2. So sine of the x, then it's a positive sign because the sine is positive value in the cosine is positive in the first quadrant. So sine x is 0.3. Okay, that's all for this question. Let's move on. All right, let's start 6D, graph of sine and cosine. So as you recall, the graph of circular functions are periodic, meaning that they cycle through the same y values for a fixed interval of x value. In other words, they repeat themselves over a fixed x interval. Now, in order for us to sketch sine and cosine graph, we know that we are going to sketch the angle against the y value for sine curve, and we will sketch the cosine curve, which is the angle against the x coordinate. So I give you a unit circle that might help you to sketch the sine cosine curve. Let's start the first one. So let's look at graph of sine functions. So the graph of fx equal to sine x given below, we're only looking at negative pi to 3 pi, and we know that sine curve keep going on forever unless we're given a fixed domain here. So what is important to take note here is that the maximum and the minimum value of the sine is 1 and negative 1. If we look at the unit circle, as I mentioned before, we are plotting. What are we sketching? We're sketching the angle against the y value. And we can see here the y value is increasing as the angle increase. Okay, as the angle go to pi and 2, the y value is 1. That's how we got that point. Pi and 2 is 1. And in this corner, and we can see here from there onward, the y value is decreasing and it go to 0 when the angle is pi. So that's why we get that corner. All right, and then the y turn negative, get more and more negative, and the minimum is at -1. So at 3 pi and 2, it is -1. And then the angle will still be negative, but it gets less and less negative and it becomes 0 at 2 pi. So when you go one full cycle, it is what we call the 1 period here. So the maximum, the distance between the mean positions and the maximum position, they're called amplitude. Okay, so the graph of y equal to sine x has amplitude of 1. Okay, so that's called the amplitude. To find the amplitude, if you are given the maximum and the minimum, you can actually find amplitude. You basically take the max minus the mean divided by 2, and that will give you amplitude. The other thing you need to take note is the amplitude is always positive. Why? Because amplitude is the distance, the key word is the distance between the mean position and the maximum. All right? Or you can say that the mean position and the minimum as well. That's amplitude. So we're looking at that distance. Okay. The other thing you should know is that for sine curve, so if we call this high tide, let's say the minimum is a low tide, you can see here from high tide to low tide is actually half of the period. Okay, so from peak to peak is 1 period, which is 2 pi. Okay, or from this point to that point, when you complete one full cycle, that is 2 pi. Okay, so the sine x has a period of 2 pi. All right, let's look at the cosine graph. And again, you have seen this cosine graph from year 11. So let's quickly go through this. So again, we see that cosine, the period is 2 pi and the amplitude is 1. Cosine graphs start from 1, the max. And as we know that, what are we sketching? We're sketching the x value against cos x, which is the x coordinate of the unit circle. So you can see here the x value units start from 1. So remember here is 1, 0. Cos of x is 1 when x equal to 0. So as the angle get bigger and bigger, the coordinate, which is the cos x, all right, the x coordinate gets smaller and smaller. So it goes to 0 when it is pi over 2. And the x value here is -1 when the angle is pi. So when x equal to pi, that's -1 here. Now, in the third quadrant, the x coordinate is negative. The x coordinate of the unit circle, which is the cos x, is negative. So you can see here the graph is below the x-axis. And up to that point, at 3 pi over 2, the x value is actually 0. So at 3 pi over 2, you can see here x value is 0. Okay, at here, which is what, 2 pi, what's the x value? It is back to 1. Okay, so we start from 1, we go to 0, and then we go to -1, and then 0, that's the x value, and then it goes back to 1 here. So the graph is almost the same as sine x. It's basically a shift of pi on 2 to the left. So let's look at this graph here. One of them is sine x, the one in yellow, the one in blue is cos. It's shifting the sine curve pi and 2 to the left. And that explains the relationships that we already studied earlier. Sine x plus pi and 2 is equal to cos x. So When you shift sine x pi to the left, you actually got the cos x. That's how we got these relationships. Okay, dilation factor. From the x-axis, it's going to change the amplitude. So that's dilation factor 3 from the x-axis. So the amplitude is 3. Therefore, the range will be from -3 to 3. The range for this one is -1 to 1. The period is still 2 pi for both diagrams. Okay, from the y-axis, dilation from the y-axis is going to affect the period. So what dilation factor? That's dilation factor 2 from the y-axis. So basically the period will be now 2 pi times 2. That's how we got 4 pi. On the graph on this side here, there is a dilation factor half from the y-axis. Now you times 2 pi by half. That's how we got a period of pi. So every pi, the graph repeats itself. Okay, that's a period. All right, in summary, so if you have y equal to a sine nx, a is the amplitude, the period will be simply just 2 pi divided by n. So there's dilation factor of 1 on n from the y-axis, so it's 1 on n times basically 2 pi. Okay, 2 pi n. Amplitude is a, the period is 2 pi divided by n. Dilation factor 1 on n from the y-axis, so it's 1 on n times 2 pi, or you can say 2 pi divided by n. All right, now let's look at the steps for sketching the sine a sine nx or y equal to a cos nx graph over restricted domain. The first thing is you determine the period and the amplitude. That's important. And then the second one is determine the scale, which is always the period divided by 4. Y is always period divided by 4, because when you sketch the sine x curve, now let's look at the basic sine x curve. Not very good sine x curve. Remember, it's like the graph divide into 4 parts. You got the first part, and then the second part, the third part, the fourth part. So if you can remember the 4 part, that make your graphing easy. So this is called quadrantal angle. Start from center, go to the max, back to the center. First quadrant, second quadrant, third quadrant, fourth quadrant, and draw with a smooth curve. All right, so that's my sine x curve. Cosine curve, a standard cosine curve, start from the max. So like this. Maximum, center, minimum, center, maximum. Again, you actually divide this by 4 parts. Got a graph that chopped into 4. So if you can section into 4 parts, that makes your graphing very easy. Everything significant, max, min, x-intercept happen every quarter of a period. So remember the shape of sine x and cos x, the basic shapes. Determine the value endpoints, if not a key value, max, min, or x-intercept. So let's start with the very first example. So firstly, write down the amplitude, which is 2 pi divided by 2, which is pi. Hang on. So, what am I doing? I'm writing the period instead of amplitude. The amplitude is just half. The period is pi, with basically 2 pi divided by 2. And the range is -half to half. Okay. All right. So when we sketch that, firstly, let's draw that, and let's look at the scale, which is the period divided by 4. So let's start pi over 4, and then you go 2 pi and 4, which is pi and 2. You go 3 pi and 4, and you go pi. So remember, sine curves start from the center. Okay, let's draw the max and write down the minimum. So center, maximum, center, which is the x-intercept, the minimum, and then the center, which is the x-intercept here. Join with a really nice smooth curve. That is one cycle. And then you start again, quarter of a period, so you add pi and 4 every time. So 5 pi and 4, 6 pi and 4, 7 pi and 4, 2 pi. Again, maximum, the x-intercept, which is a center, the minimum. Draw a line here so that you know that you can't exceed that negative half. Draw a faint line that you can see only, and then you have now 2 pi, and you join back nicely with a smooth curve, and then you go to the other side again. You repeat negative pi and 4, negative 2 pi and 4, negative 3 pi and 4, negative pi. Again, go to mean, center, and go to max, and go to center. Let's go in that directions. Oh, that's bad. Okay, it's hard to draw on my pen. Okay, make sure that you have the half that doesn't go over half and doesn't go below the negative half. Okay, I'm going to look at this nice graph that's drawn here already for you. Okay, all good. Let's move on. Okay, example 8 and example 9. Pause the video and you might want to fill in your note first and then come back and check your answer. Okay, let's sketch this together. Check your answer. So firstly, you need to write down all the important information, like the period. So the period here is 2 pi divided by, be careful, not 2 but 2 pi, because the coefficient of t is 2 pi. So 2 pi divided by 2 pi, which is 1 in this case. Now the amplitude is 3. Amplitude is that numbers, which is 3. And always remember, amplitude is always a positive value. The range, which is the center plus the amplitude, and the center minus the amplitude, which is -3 to 3. So unless there's a vertical translations, otherwise the center is always 0. Okay, the scale is always the period divided by 4. Why divided by 4? Because we are always looking at the quarter of the period. And remember the basic sine curve, like that. So basic sine curve, start from the center, going to the maximum, back to the center, minimum, and the center. So you divide your graph by 4 parts. So we can do the same thing here. Use a ruler to draw your x and y axis. Careful, it's not x here, it's given as t. So we follow whatever that's given. T is my horizontal, is my horizontal axis, which is my t-axis. Okay, now let's put our scale nicely. A quarter, 2/4. Make sure they're equidistant. If 1 centimeter represents a quarter, let's go for equidistant. 3/4 and 1. And that's all we need. We need to sketch a graph from 0 to 1. And the maximum is 3. The minimum is -3. Let's do 3. Again, make sure our scale is equidistant. -3. I usually draw 2 faint lines only for your eye to see. Use a ruler or dotted line. Okay. All right. Remember sine curve. Start from the center, 0, 0. Go to the max, x-intercept, which is center. Go to the minimum. Go to the center. The quadrantal point, 5 quadrantal point. And then you join with a smooth curve. Smooth curve. Okay, and label all the endpoints: 1, 0, 0, 0, 1/4 3, and so on. Okay, all right, that's what we have for example 8, and now we move on to example 9. The other thing I want to warn you guys is please draw your sine curve properly. I don't like to see sine curve like that. Know your sine curve like one side big and then the other part, the other half of the half period small. So must have a nice smooth curve, and neither it looks like that. Okay, so I'll be checking your homework and make sure that you got a good graph. Okay, let's move on to example 9. Again, let's write down all the important informations. The period, it is 2 pi divided by half. Okay, coefficient of x. 2 pi divided by half will give you 4 pi. The amplitude is 3. Be careful, amplitude is always a positive number. That negative means reflections in the x-axis. The range is the center plus the amplitude, the center minus the amplitude, so it's -3 to 3. The scale will be 4 pi, which is a period, divided by 4. It's quarter of a period, which give you pi. Again, let's draw it nicely. That's my x. X is from 0 to 4 pi. So divide by 4 pi, 2 pi, 3 pi. Maximum is 3. The minimum is -3. And again, draw 2 thin lines only for your eyes to see. And this is a negative cos. So negative cos start from the minimum, go to the center, max, center, mean. That's my cosine curve. All right. So start from mean, sorry, minimum, because it's negative here. So center, maximum, center, minimum. Because we have organized our graph in such that it's go by the quarter period, so that makes the graphing really simple and easy. Enjoy with a smooth curve. And label the endpoint. 4 pi, -3, 2 pi, 3, 0, -3, and so on. Okay, now again warning, please don't draw your sine curve like these and these and these. Nice smooth curve. Look at this nice smooth curve. Smooth, not in, out. Okay, nice smooth curve. This is a good cosine curve. All right, that's all for now, and I shall see you in exercise 6E. We meet again. Now, what I want you to do is, I want you to complete 6D, and that's it. Thank you.